Ryan Faircloth. Welcome to Splunk Connect for SNMP. This is a B-Sides chat for 2021. I am glad to have your time. And no, I'm not kidding. We are talking about SNMP. Forward-looking statements and such. I am a product manager at Splunk. I may talk about things that have not been released yet or futures. Please keep in mind all the rules about that stuff. Okay. Splunk Connect for SNMP is a cool new product. It's a really boring product. I like to talk about things that are boring. You might know me. I am dry. But I'm bump. All right, Splunk Connect. So what are we doing? Just like all Splunk Connect products, these are all open source connectors that exist in that space between our data source and Splunk Connect, Splunk Enterprise and Cloud Services. Administration can be delegated to administrators that are, hey, not your Splunk admins. So we try to move the work to the people who are accountable, responsible, impacted by it, while keeping the parts that are Splunky over on the Splunk side. Doesn't mean a Splunk admin cannot manage this tool. It just means a Splunk admin doesn't have to. Or isn't the roadblock or the barrier for that if that is not the appropriate thing in your environment. And Connect products can be made highly available, resilient, scalable using methods that align to the source system. So while Splunk has its methods of being HA and DR that are appropriate for big data architecture, that isn't always the way the source systems work. So connectors are freed from the big data architecture to work as source systems do. And that's one of the elements you'll see in this product as well as others. So what does SNMP actually do? If you're not familiar with it, what rock have you lived under? I'm kidding. What SNMP does is let us get low-level utilization of a component like a network device, interfaces, CPU, memory, disk, from appliances that are otherwise closed where we can't install agentry. Gets trapping, which is what immediate failure just happened, which is a level of fault below things you think of like syslogs. So where syslog is a log, think of trapping as if it was a direct alert. You make opinions on logs, but traps are just do. Or just act or ignore. What is the current value of specific config? This can be really powerful because you can detect things like what is the software version running on a device, management IPs, interface IPs, MAC addresses attached. All can be very useful. And it cannot explain why things are utilized in most cases. What do I mean by that? Well, I might see an interface or a firewall interface that is used in the 90% range, and that's probably a concern. But utilization alone doesn't tell me what's utilizing that because thousands of devices could be contributing. I use things like net flows powered by or connected via Splunk Stream to handle things like why something's used. But aggregating thousands of flow events to determine utilization is inefficient. So collecting metrics to give us actual utilization at point of time is a super useful, efficient way to manage our capacity to get an efficient answer that we can react to without waiting for aggregation. It doesn't replace syslog, like I've said. It's a lower level protocol in most cases. It is not an alternative to, it is an addition to that gives us different points of observation in our network architecture. That also does not replace agents for hosts because it is a minimal viable type of logging. What we could get from a universal forwarder is far more detailed and useful for a host monitoring or a Linux or Windows box. But it's perfectly adequate for network and appliances. Well, often it's the only choice. So that's what we're going to do. Okay. Key attributes that you might be interested in builds on the approaches we used in Splunk Connect for syslog. Deployed into network zones using self-contained Micro K8s, so we can keep it inside of our secure network enclave. We don't have to expose SNMP to untrusted network zones. We can have many or few of these, and it's scalable. It's designed to be CI friendly, headless deployment, low touch, very automatable. Some things you won't see is there's not actually a Splunk UI for this because it's not needed. It'd be extra. It's just simple inventory driven that you can sync from whatever tools are appropriate to you. And it can be co-deployed with Splunk Connect for syslog. So while you might need to vertically scale your environment, you can get more efficiency by using resources better. Getting some elasticity or at least efficiency. We have I did mention this before, but it can be managed by not a Splunk admin. So you can delegate it to your network team if that's appropriate to your org. or managed by Splunk admins or somebody else, but it gives you good separation of duties to help you in your environment, and support for thousands of Mibs out of the box. That could always be not enough Mibs. So if you might ask, well, how do I get more Mibs? Simply just ask. Give us a link or an issue on our GitHub tracker, or open a support ticket with the Mib that you need added, and we will get that done for you in pretty short order. So how does all this fit into the big Splunk picture? Glad you asked. We have devices over here on the left. They can send traps. They will accept polls. Not all devices do both, and that's an important thing to be aware of, is that's not up to us. That's up to the device vendor. Some will trap, some will poll, some will do both. Some will trap and syslog, but not accept polls. You get the idea. So the network trifecta of trap, receiver, poll, or syslog is very important. You're going to note that we're introducing OTel collector into the Splunk architecture with Splunk Enterprise Cloud for the first time. This is a nifty progress towards truly open edge agentry. Where we start out with this is traps and polls get converted to metrics for SignalFX. Splunk Infrastructure Monitoring, formerly SignalFX. Or just get sent to Splunk Enterprise Cloud. You might wonder, it's HTTP in both cases. These are open protocols, very firewall friendly. It is demo time. So I'm going to pause briefly and switch a couple windows around and come right back. Okay. Welcome to the Splunk Connect for Syslog getting started page. You'll find this link in the presentation. Here it is. So we simply scroll down and we're going to get started and walk through the entire process. So the first thing we need to do is set up our Splunk enterprise environment. So a Splunk HEC token with no restrictions, or a HEC token with access to internal NetOps, NetMetrics, or whatever combination we use. In this case, I'm going to use SNMP and SNMP metric and SNMP. So first, I'm going to switch over to my Splunk instance and go over here to indexes. I set up the metrics type already. I'm going to set up the SNMP events index now. Bear with me. New index, SNMP. This is an events index, and I don't really care enough for a demo to set any more details. You also see that I'm going to need an SNMP metric index. So I call it SNMP underscore metrics, call it metrics, and hit save. This is important. If you send metrics to events to a metric index or metrics to an event index, it's not going to work out. You'll have errors, and it's just a pain to troubleshoot. So please do pay attention to the overall settings as you execute them. Okay, so that was the first thing we did. I'll get back to that in a second. Okay. We need to know the URL with a trusted certificate. Yes, you can bypass this, but if you know me, I'm a security guy by trade. So I'm going to tell you, you have to do it right. If you do it otherwise, well, that's up to you. And we're going to set up in my case, I'm going to use Ubuntu, but you can use Red Hat with snapd to get to Micro K8s. We are cliff noting the version of the installation process because it really is easy, pretty much 4-step process. We're going to set up Micro K8s. We're going to check for the complete status, and we're going to install it. So we have a cool tool to generate VMs, and I've generated them already. So here's my SC for SNMP VM. I'm going to copy my password and click login. Hey, yeah, I just allowed to log in. Thanks. All right. So yes, all good. Okay. Paste my password. All right, hey, this is a brand new box. Hey, it's got a few updates. We'll have to deal with that in a second. So sudo apt-get update. Yes. I like to have my boxes up to date before I do anything with them. I encourage you to do the same. Doesn't take very long. After we update, if you're new to Ubuntu, we will simply upgrade and off it goes. Excellent. All right, I'm going to pause while this goes. All right, welcome back. All right, so my operating system is up to date. I'm going to go get my instructions. First command is to just install Micro K8s itself. which is a relatively fast process. Okay. Waiting, waiting. After this completes, there is a command to wait for it to be ready. Okay, now I'm waiting for Micro K8s to be up and running. This doesn't take very long. Okay, Micro K8s is ready. It's listed out a bunch of things that we can use. The very next command takes a little bit of commentary. You'll see that the sudo Micro K8s enable, which means we're turning on some features. We are turning on an internal DNS cache because reverse DNS without cache sucks. And it needs to be able to do that with your internal network. So the default configuration of K8s is to query a public DNS server on your internal network. That's probably not okay. So we need to do the right thing and replace that with the right IP. We use a thing called Metal LB, which isn't much talked about on normal days, but it's one of the things that allows us to do some magic for horizontal scale and HA that'll, if you need it, that's possible in your environment. And we do use, make some use of Helm 3 when installing the installing monitoring for Micro K8s. Okay. Now, in my environment, I'm using a local or Amazon AWS lab and a little VPC, so I don't have a DNS server that I can use. So for lab purposes, I'm actually going to skip enabling DNS. This isn't for production, just kind of pay attention to why I did that. Reverse DNS won't work for us. What I do need to know is the IP address that I'll be using. So if you plan to make this HA, we mentioned this in documentation, when we first set up, you need 2 IP addresses. One IP address will actually be assigned to the Linux host like a normal IP address would. The second address isn't configured in the host. Don't configure multi-homing. We're going to tell Kubernetes to take it. So in this case, I'm never going to make it HA. So I'm going to use 10.202.6.253, which just happens to be my host name in AWS. And that is a /32. There's just one, okay? In the future, had I used 2 IP addresses and used one that wasn't my host's management address, we could expand the cluster to be 3 or more nodes, and that would allow us to have a naturally highly available clustered IP without external load balancers, so it'd be super performant. That's not what we're doing here. Just understand that it's something that you can do, okay? For convenience sake, I like to alias this. So I'm going to do that here. Now I can do kubectl. Okay. How do we set up the environment? So the first few steps here, and we're not going to do that for this prezo, is to set up monitoring for Micro K8s. We're just going to get right into what we're doing. So the first thing I need to do is go clone my repository. You can download this and expand it if you can't get access to GitHub from the server. Clone is faster. CD into the directory. Just do a quick ls, and you see that I have some files here. What we're doing is deploying. So we've written a quick script. You can take this apart and use it how you want if you need to. But the short version, okay, is cut and paste. Now, the problem is if I actually run this, it's going to have the wrong hosts and the wrong host for tongue-tied, I apologize. This will have the wrong host for monitoring. So oops, I shouldn't have done the direct copy and paste. You know how that goes. So I'm going to use another window just to give myself something to edit with, copy and paste over, and I'll get back to it in a second. But I need to replace this with the correct URL. Okay. Now in my environment, I have a cool tool for creating Splunk stacks. And I am setting this up for my T-shirt corp. So this is the URL that I need here. Okay, almost. It's actually an S and 8088. So 8088, I see that there. Oops. Okay. Never mind. And I need to go over here and make this an S there. And how this works Okay. Well, normally would work. What did I do? Oh, oops, I forgot to sudo. There we go. Splunko. All right, here we go. We have Splunk Connect for Kubernetes installed so we can monitor our environment. Awesome. All right, moving on to the next step. Oh, forgot to pop D. I CD'd instead. There we go. All right. So it happens when you don't follow your own instructions, literally. All right. So the next thing we're going to do is we're going to create a secret. This would be used if I'm not going to configure Signal X, or actually, sorry, this is used for both. So let me get this command. And I'll do the same thing. Just configure it for, do as I say, not as I do. Okay. So you break this command apart real quick. This is where my Splunk URL will go. Now you notice this one is a little bit different because it's from two different pieces of software that work together. And that's just the way it is. So let me go over here and I'll get my URL. It is HTTPS. Paste. You see that I have that correct. The rest is included. Skip verify is true, and I need a token. I should go get that here. And that is over on Splunk. I'm using a single instance, so it's really easy to set this up. Or on Splunk Cloud, it's also easy. You know, there's a few more steps on-prem, but the way that'll work is I'm going to go into HTTP event collector and add new. That is SNMP demo, and I'm going to hit next. Like I said, my best practices don't restrict indexes on trusted systems. It is more trouble than it's worth. So I leave that blank, which means all indexes present and future. And then I get my token here and paste. Okay. I am not setting up SignalFX for this demo. So I'm taking off those two lines. And now I can copy and paste this over to my environment. This secret is used to authenticate. There we go. Oh, nice. There we go. Don't you love live demos? There, created my secret. Okay, now that we have our secret in place, we're going to configure. Okay, so there are some words about what we're actually doing here. Hotel is placed in that configuration. All right, good. So at this point, we are good to go. We can actually check to see if it's applied here. Okay, so we need to do a quick deployment here. So I've CD'd back up to the deploy parent of the deploy folder here. And I'm doing a copy and paste. Now there is one command in here we need to edit. So you see this has my IP address, or this is the IP address that we gave my Meadow LB 202.6253. Okay. And we're going to do a quick edit of the files. All right. I am root, and you might have noticed that I forgot to move my alias over. So let me fix that. So now we've created all these files. Do as I say, not as I do. You know how that goes. Okay, what this did is edited the files and then it applied them. Okay, so they're all created. Now I can do a cube CTL get pods if I want to see, and these are all getting created. You'll notice that my SCK or my Splunk Connect for Kubernetes containers are crashing. This is a quick demo that I'm doing for you, and I'd be worried about that normally. What this means is I got the token wrong when we first started. So now you'll see that most of my containers are running. These are the two that I'm waiting on. Okay, now I have my traps, my workers, and all of my internal stuff up and running, and we're in good shape. So now what I should be able to do is do a couple of quick trap tests. So this command right here. Now you've noticed I'm working in this window right here throughout the day. That's my SNMP server. Over here, I have a Linux box because that's easier to acquire for me than a Cisco router. But this is simulating one of my pieces of hardware. So what I'm going to do is do a Control V, and I need to go over here and change the IP in this command, which is what we say in the docs. 10.202.6253, 10.202.6.253. Okay, so that should happen. And if all goes well, we're going to see that. Okay, so we're going to go over to Splunk Search pretty quick here. Index equals star. And we have a nice straightforward event. I'm going to talk to you about the event format that we're using here, which is listing the same thing multiple times. This allows you to see the object type, the name, the OID, and the translated value. So if you have legacy content from old systems that used OID equal or used second value in the array, you can use that, or you can use the Mibs string. So we tried to make this really easy to port content fairly literally from existing systems for you. Okay, so that takes care of SNMP trapping. Pretty straightforward. So now we're going to do one last thing, which is set up the polling. So I need to apply some manifests. And just as kind of a reminder, this is all one-time setup. Essentially, till this point, you've done it once, you're done, except for upgrades. So now we have our pods, and we've already seen those. We're going to test the polar config. So this is done through a config called Splunk scheduler config.yaml, and it's done this way. So first we will apply it. And we see that it's unchanged. Now we can either edit this file on disk or actually edit it live to do some basic work. So in this case, I'm going to hit edit here. All right. That brings us up, and we have some basic things in here. So what is this? The first thing we see is the IP address of the host I'm going to poll, and that is over here. So let me go get that. You're normally going to get this kind of thing from some kind of internal inventory, not from a web app like I am. All right, so we can import this to make it nice and easy, just not here. Okay, so host version is the protocol that we're using. So I need to see my community string is public, and that is a read-only string. That's important. And profile, we'll talk about that in a second. And then frequency. The profile I am going to use to start this one off. I'll talk about that, bring that up here and let you see it. Okay. Okay, so the profile I'm going to use is just called router in this case. And I want to collect it every 30 seconds. All right, that's going to give me some basic interface utilization and some basic details. So here I go and hit right quit. Now that's been immediately applied because it's live. And in about 30 seconds, I should see some data. All right, we waited for about 30 seconds, and I need to get a quick cup of coffee, but I'm back, and thanks to the magic of video, that's okay. So after we finish polling, we have a couple of pieces of data. You will notice, hey, this is beta, and I'll have this fixed before you see it, but the source type for SNMP Traps is wrong. That's not what that's supposed to be, but you see what we're going after, which is I have some metadata, which is the location of this particular device sitting by on the dock by the bay. Should have been on some beach somewhere, and how long it's been up. So its uptime has been 1, 2, 3. So that concludes this presentation. Thank you all for attending and have a great day.